Hi everyone, so this is the start of Unit 3 today, and officially we're in second quarter, so that's exciting, a fourth of the way through a year. So Unit 3 is focused on triangles this is another split unit, so 3A will be focused on triangles, and then 3B we're going to look at polygons. So starting off today is just kind of some basics. So we're going over some vocabulary, some things that you've probably already learned but maybe need a refresh on. And I'm going to do kind of the word version of everything and then give you a drawing or a picture with that as well in case that helps you more. I would recommend you draw both of them, okay? So that way you have the words but you also have the picture to look at and match up anything later. So first of all, just starting off with classifying triangles. So like, how can you describe it or name it? And there's two ways you can do that: by their angles. So, and again, like I was saying, this is probably something that you know, but just in case. So first of all, acute, all right? You know that is a triangle with all angles. I'm going to do the angle symbol like that. Less than 90 degrees. So maybe it's like that or something. Oop, went too far there. Hold on. So when you have an acute one, they're all going to be less than 90, not just one of them, okay? A right triangle, okay, is a triangle, I'm just going to abbreviate there, with one 90-degree angle. And they can't all be 90 because all three together add up, all three angles of a triangle together add up to 180. So we couldn't use more than 190 and still fall within that 180. So if it just has one, remember it has to be marked. Make sure it is marked with your square sign. All right, an obtuse triangle is a triangle with one angle that is greater than 90 degrees. Again, just one of them, or we would go over that 180 degree max. So it might look kind of like that. Okay, second way to classify triangles is by their sides. So scalene is a triangle that has three unequal or non-congruent sides. It's my triangle symbol there. Sorry, it's a little messy. So a triangle that has three unequal or non-congruent sides. All right, so basically each one is different. So maybe I have a 2-inch, those little double apostrophe that represents inches. So maybe a 2-inch side and a 4-inch side and a 5-inch side. Okay, they're all three going to be different. So scalene. All right, second one is isosceles. So this is a triangle that has two congruent sides. I'll say equal or congruent. Okay, so maybe the bottom here is 1 inch, and then these other two sides are 3 inches. Now, thinking back, remember, if those are both equal, we show that by the single line on there, showing that they are congruent, okay? Sometimes when given a problem, they may not mark that for you. You may need to go back and clarify that, okay? All right, lastly, equilateral or equiangular. So this is a triangle that has three congruent sides which also makes their angles equal as well. So I'll just say and. All right, so maybe each of them is 3 inches, and I'm going to mark that they're congruent there. And since it's equiangular as well, I would show congruent with our little line there. Okay? All right, so different ways to classify there. All right, moving on now to actually how that looks when you're going to do it. So if you're given a triangle, you want to look at the information they give you, and then I'm going to classify it by the angles and by the sides. So we should have 2 answers on each of these. So for number 1, okay, they all the sides are 5.7, so that's congruent there. All right, so I'm going to write angles and sides. I'm going to write that on each of these actually. Go ahead and write that real quick. So if we're classifying them both ways, so we don't forget to do both, okay? All right, so up here, number 1, this first one, all 3 congruent sides. So that tells us it is equilateral. Slash, they also have all those equal angles, so I'm going to say equiangular. All right, and now to classify by the angles. So I don't use the equiangular as my angle classification. I want to say either acute, right, or obtuse. So these are all 60, so they're all less than 90. So I would say acute. All right, 2. So it's probably easiest to start off with the angles on this one. So I have a 39 degree, 102 degree, and 39 degree. So there we have one obtuse angle. These 2 are congruent. But so if I have just one obtuse, that makes it an obtuse triangle. All right, and then looking at the sides, well, I have 2.5 and 2.5 are congruent. And if you're noticing, when their side is congruent, the angle opposite them is also congruent. So like this 2.5 goes to 39, that 2.5 to 39. Well, same side measurement, they also had the same angle measurement. Okay, but sorry, sidetracked. Looking back there, so 2.5, we have 2 sides that are congruent, so that is an isosceles. Okay, I will go ahead and pause the video here so that you can give 3 and 4 a try. All right, hopefully you have paused and are checking it now. So number 3 had a right angle here, which makes it a right triangle. Okay, and classifying by the sides, well, none of these side measurements were equal, and so that is a scalene. Okay, 4, looking at the sides, or the angles, sorry, we have 53 and 53, congruent, 74, all right, well, the congruent doesn't necessarily classify it, though, by an angle. It just tells us that they are, and I can mark that. It's a good habit to get into for what we'll get into later. But they are all, we have no 90 degrees, none that are obtuse, they're all acute, so acute triangle. And our sides, again, we have those sides that match up, 9.8 match up with their angles, so the sides congruent, so are their angles. So 9.8, 9.8, and 11.8, 2 congruent sides tells us isosceles. Okay. All right. This is kind of thinking back a little bit here. So it says triangle ABC has the following vertex coordinates. Classify the triangle by its sides. Justify. So on those previous questions, they gave us the measurements for the sides. Here they do not. So that's what we have to do first, is find what those lengths are, because that's how we classify a triangle by its sides. So, all right, find the length of sides. And that is going to be the same as the distance. So that's why I said we're thinking back there. We have to use our distance formula here. So if you remember those questions from Unit 1, where you had the triangle on the graph and you had to find the perimeter, that's essentially what you're doing, but you're not going to add them up, okay? So if you, I've seen a lot of mistakes on this because we're getting things confused and not showing much work. So please be writing things out with this. So if it helps you draw a picture, okay, it's like ABC, all right, well, I need to find AB first. Okay, and then that's where I do, so the distance between the x's. So, or you can think subtraction. So -3 minus 2 is how you want to think of that. Or how far apart are they? I've seen quite a few people thinking, well, it's a negative. That's fine. You can do that as long as you put the parentheses before your squared, okay? Because we can't have a negative distance, all right? Now I do distance between the y's for A and B. So A is 2, B is 0, so that gives us 2 apart. All right, then I basically just solve this part out. So that's 25 plus 4 is the square root of 29, which comes to approximately 5.4 for that first side. Okay, now I'm going to do BC, because if I had this triangle, it would look, whoa. Well, I don't really know the measurements yet, but A, B, C, if it helps you to kind of fill them in and label it as you go, then do that. Okay, so now I'm going to do BC. All right, so B and C, the x's 2 and 0. Well, that's 2 apart, so 2 squared. Plus, well, 0 and 4 for the y's, that's 4 apart. Okay, so that's going to be 2 squared is 4, plus 16, so that's, I'm working this one out a little bit more for you, is the square root of 20, which is approximately 4.5. That's BC, so that goes here. All right, and lastly, I need AC. And this part is kind of why sometimes you guys don't know which coordinates to be picking, so that's why this picture can kind of help you see. All right, well, A and C, so I need this one and this one, okay? So AC. The x's are 3 apart because it's -3 and 0, so 3 squared, plus the y's are 2 apart, it's 4 and 2. So it's going to be 9 plus 4, or the square root of 13, which is approximately 3.6. Okay, so now look, we have 3 unequal sides. So that is a scalene triangle. And it says justify here. Your justification could be your work for one, or you could also write out like unequal sides. Okay. All right. Go ahead and pause here. See if you can like totally set up 6, because we have done this before. It's just thinking back a little bit with that distance formula. Be extra careful in picking your x's and y's, like this part, because that is pretty much always where I'm seeing the mistakes. Okay, so draw your picture out first, set up your square roots, and solve from there. Okay, so pause and solve. Okay, if you're coming back from solving, I should have AB, and check your work, not just the final answer, okay? So AB, the x's were 3 apart, so that's 3 squared plus, oops. All right, and the y's were 1 apart. I think my pen died here, sorry. equals, so add those up, and that's going to be approximately, sorry my pen died, so this is really messy right now, I'll have to charge it, is approximately 3.2. All right, BC, yeah, this isn't going to work very long. Try this again. BC was the x's were 1 apart, and the y's were 3 apart. Okay, so 1 plus 9, the square root of 10, which is approximately 3.2 again. All right, and then we had CA. The y's or x's were 2 apart, and so were the y's. So that's 4 plus 4, so square root of 8 is approximately 2.8. Okay, so that gives us, we have these two equal sides. So triangle with two equal sides is isosceles. My justification would be two congruent or equal sides. All right, now triangle segment. So this is just kind of some vocab of what you're going to be seeing. So you're definitely going to need to know like what these things mean, because they help you find kind of congruence, and they help you find more congruent sides and things from knowing what these are. So just going to define these at first, and then we'll draw a picture of each of them. So a perpendicular bisector is a line segment I'm trying not to talk while I'm using a pen because I know it's a little loud. That is perpendicular to a triangle side and passes through the side's midpoint. And again, we'll draw a picture here in a minute, further down. Okay, altitude. So you want to think altitude kind of tells you how tall the triangle is. And it's going to be, all of these are segments as the says up here, right? Okay, so altitude is a line segment from the vertex actually I'm going to say from a vertex drawn perpendicular. We're actually going to do the symbol here, make it a little bit shorter. So drawn perpendicular to the base. And the base is going to be the longest side. I'll write that. And the altitude gives the height of the triangle. Right. Okay, next is the median. So this is a line segment that connects a vertex to the midpoint of the opposite side. Okay, and now angle bisector. A line segment that bisects. If you remember bisects, that means cuts in half. a vertex of a triangle. All right, so now we're going to draw a picture of what each of these looks like. Okay, altitude. So again, so it goes from the vertex, all right, and then it's drawn perpendicular to the base. So our base is our longest side. So here that's going to be this one. That is our base, okay? So I have to take this from the vertex here. I'm drawing a segment that's perpendicular, meaning it hits this at a 90-degree angle. So draw that the best you can. Make sure you specify that's a 90 degree. So that would be our altitude. Also our height. Okay, 8, angle bisector. So that's a line segment. It's going to go from one of the vertexes and cut it in half. Okay, so I could do this in 3 locations. I could do it in any of the vertexes there. Okay, I'm just going to pick the top one. I'm going to draw something wrong first, so don't draw this part. Maybe if I did it like that. Okay, well that's not an angle bisector because this and this angle are not congruent. So you want to make sure that you make it look kind of accurate on that. So angle bisector is going to cut that in half and just do it the best you can. Down here is not going to be a midpoint or congruent or anything. I do need to show that this is a bisector though by showing that these 2 angles are congruent. All right, median. So median, think of like in a road, okay? Well, they're in the middle, all right? So it's going to be a segment that goes from the vertex and it's going to go to the midpoint of the line, the side opposite it. So I'm going to go across to this one, and I want to kind of plot my point first of where it is in the middle. That looks about right. Oops, I got really off. But so that would be the median. Well, now I know that this segment and this one are congruent because that's what a median does. It goes to the midpoint over here. So a triangle can have 3 of these technically. So I could go from this vertex down to that midpoint. Well, that makes those 2 segments congruent. Or I could go from here across to that side, which makes these 2 segments congruent. So it has 3 options there. Okay, so 10 is perpendicular bisector. I think that's the only one we haven't drawn yet. Okay, so, and then I'm going to have you do 11 and 12. But the perpendicular bisector, so it's going to be perpendicular to a triangle side and passes through the side's midpoint. Okay, so this one looks a little bit different. I'm just going to pick, it doesn't really matter which side because we're just drawing an example. So I'm going to do the bottom one. So let's say this is the midpoint. Well, first I have to show that. So I'm going to make this side congruent to that one to show it's the midpoint. Okay. And then it says it is perpendicular to this side. Okay. And passes through its midpoint. So it just draws up. And I do have to show it's perpendicular. So it looks a little bit different. It's just bisecting this segment down here, or this side. All right, so go ahead and pause and take a minute to try to draw 11 and 12. All right, so if you've paused on 11, you had to draw the segment from this point to this side because this line was the base because it was the longest. So I have to draw that from there. So this is my altitude / it's the same as the height. Okay, Okay, median, you can just pick one. You could have drawn all three if you wanted, but if I pick this vertex, then I need to connect it to the midpoint on this line. And I want to prove or show that those two segments are congruent now. You could have also done it from this vertex and shown it like that, or from this far one and shown it like that. Oh, I just realized that is all for today's actually. So that one is all done. So again, today's pretty simple. It's just kind of vocab and getting familiar with that stuff, okay? So I would really work on, if you have a little extra time today, reading back over these, maybe reading over them kind of throughout this week. You do need to have these things memorized because it is stuff you've already kind of learned at one point, so it's refreshing. Maybe not this stuff down here, you maybe haven't learned that yet, but the others you would have. So getting these things kind of down, memorized, so read them to yourself, redraw them, whatever it takes to kind of help you study and help you memorize those, okay? So, all right, good luck, and talk to you next time.